Hello everyone, I'm Dr. Zia Tahir, and this video tutorial is about frame analysis or region jointed frame analysis in Abaqus. So this is work example of chapter 4, rigid joint frames from the book Introduction to Finite Element Analysis using MATLAB and Abaqus, and that is 4.7 analysis of simple frame with Abaqus interactive edition. So that is the frame, and these are the cross sections. So material properties or mechanical properties for the frames that is given, and the section properties are given. So in Abaqus, three main steps: model, analysis, and results. So I am going to perform that one. The first one is model, and before model, you need to check that you are using the right set of the units. You can either use Newton meter Pascal or Newton millimeter megapascal or Newton per meter squared. So here all dimensions are in meters, units are in kilonewtons. So I need to convert them into Newton per meter. And here section for the columns, these two columns. So that is a section. And for these two rafters, so that is a section. All these are in millimeters. So I have converted them into meters. I'll follow step-by-step procedure to model, and these are the steps for this problem. The first, you need to set work directory. So this is a directory or a folder in which you want to save all your model or files. So I have here chapter 4, and I want to save everything there. So I'm going to copy it, and then here I'll go file, set work directory, and here is now the work directory where I want to save everything. So in modeling, further I need to go part and create part. So for that purpose, you can use that model tree, and or you can use that module. So I am going to rename that as, let's say, chapter 4 and example, and I'm going to save that whole model as chapter 4 example. So that is, I have saved it. Now for the part module, part, I can simply double click on part, or I go to the part module and I simple click on that create part. So for create part, it is a 2D part, deformable, and wire, and approximate size of that. So approximate size of that model is, that is a double of the maximum dimension. So here the maximum dimension is 14 meters. So double of that, let's say I'm going to do it as 30. So continue. Now you'll get that grid. So I have coordinates here: 0, 0, 0, 6, 7 and 7.5, 14 and 6, and 14 and 0. So these are the coordinates, so of each point which I can use to draw that frame. So it's a select the section for the wire. So here is, so you need to use that wires, connected wires. Okay, so I'll use here create lines, connected lines. So I'll start from origin, and then I go 0, 6, or here you can enter coordinates 0, 6. So you will get that one. And the next coordinate is On horizontal axis 7 and on vertical axis 7.5. Okay, so next coordinate is 14.6. So I can do it manually like that. So that is 14.6. You can see there the coordinates as it moves. So that is 14.6. And then the last one is 14.0. So that one is cancel procedure and then auto fit view. And with that, create isolated point. I'll check the coordinates. So that is 406, that is 7.5, that is 14 and 6, and that is 14.0. So I'll go cancel procedure and select the section for the wire and sketch the section for the wire. It's done, and you can see it. The sketch of the frame has been drawn. Okay, so the next step is in property module, you need to create material, and then modulus of elasticity is 200 gigapascal, and then Poisson's ratio is 0.3. So I'll go there. Now you have two options. Either go property module, and in property module, you have option create material there. Okay. Or otherwise, here on material, double click. Material is steel. Then you can add any description of that and any material behavior, but it's a mechanical elasticity and then elastic. And I'll add mechanical properties 200 e raised power 9, and then Poisson's ratio is 0.3. So that is you have created. So here you can see the material steel is created, or here you can see the material steel is created with that mechanical properties. Next step is create profile, and you have here two profiles, one for the columns and the other one for rafters, and you need to add all these mechanical properties. So here you can use property module, and here is create profile with single click, or you can go here profiles, double click, and then columns, and it is the I section, continue. Here L is the height of neutral axis from bottom flange, and both of these sections they are symmetrical. So neutral axis lies in the middle of the section. So L for the first one is 163 millimeter, and for the second one is 179.5. So for columns, you need to add all that information for columns. So all values LH B1, B2, T1, T2, and T3 for columns has been added. Then you need to create another profile. So this time just click on that, and that is rafter. So rafters, I section, and now you need to add all the values for rafter. So now for the rafters, all information has been added. So click OK. So now you have column and rafters. So you have created section. The next one, you need to create section, and then again there are two sections because two profiles are associated. So I can go to property module, and then here I will go for create section, or you have section here, just double click on that, and then section is column. Columns, beam, category, type is beam, continue, and then profile name is columns, and material will that as it is, leave that everything as it is. So now you have in section, you have created columns. Now I can click here, and now rafters, category beam, type beam, continue, and then here you have rafter. So, and you click OK. So now in the sections, you can see In the section, you have columns and rafters. In profiles, you have columns and rafter and shape is I. So the next step is you need to assign section. So for columns, you need to assign columns, and for rafters, you need to assign rafters. So for that one, you can use that module, property module, and that is assign section. Or in the model tree, you can go here section assignment. So, and then you have here done, and sections are columns. Okay, then you can here assign section, and you select that rafters done, and then you go here rafters and okay. So done. And then you can see that these are the columns selected, and then rafters, they are being selected. So the next one is you need to assign beams orientations, and beam orientation. You need to go property module, and then you have here beam orientation. So let's say I click this one, done, and that is orientation upwards. So leave, okay, press OK. Then the second one, done, and that is a beam orientation. Okay, and then that is a tangent, and then third one, done. Okay, and then the finally you'll have here done, and then okay. So okay, so you have now created, uh, you have assigned beam orientation. Yeah, then you go to the mesh. So in mesh, you can do seed, mesh part, and assign element type. So here, okay, so that is done. So you can click here, mesh. So you will go into the module, mesh module. First, you need to do seed edges. So I'll select all that, and then I done it. So you have option, you can go by size and by number. So let's say I'm going default as 4, apply. Okay, and then you can see this part is being meshed, and this one then mesh part. Let's say okay to mesh part, say yes, and then assign as element type. So you're going to select that, done, and then element library is here, geometric order, beam, and then you select that one. Okay, so it is B to 1, done, and you completed till you reach their assembly or mesh. And the next one is assembly, and you need to create instance. So you'll go here, that is assembly tree, and you can click on the instance, or you can go here in the module assembly create instance, and you set okay, and you will see that the frame is there. Okay, and after that you need to create step. So for step, you have here the steps, or you can go there and in the module you step, that is step. So it is static load and general procedure type, and then static general continue, and leave everything there. So you have static load there. The next one is you need to assign boundary conditions. So boundary conditions for this case, they are pin sports. So I'll go there, and sorry, these are pin sports. So in the boundary condition, it is I'm named as left support, and left to step is initial. So you can go displacement rotation and select that point, done, and U1 and U2 are restricted for pin support. Okay, and you can see that boundary condition has been created. Now the next one, I'll go right support, and for right support, step is initial, mechanical rotation, displacement rotation, continue. I'll go there, done, and then U1 and U2, and you click OK. So next I need to apply loads. So for loads, two loads are along global y-axis. So these two loads are along global horizontal axis, and these two loads are at some angle. So what you need to do is you need to apply these two loads along on these columns in global direction, and then these two loads in you need to apply in local direction. Okay, and now this is the and for that one, so the load and the axis of that member, the angle should be like if we are so that is global axis, so these are perpendicular to the global axis, and here that is perpendicular, but the angle is minus 90 or 270. So if that is the axis of the rafter, so then the direction is here, we will take that as negative, and for that one as positive. So on uh, on left column is 15, on right column it is 10, so I'll go there in the loads, and here load, you can just name it as load 1. Step is static load, mechanical, and that is line force, line load. So continue, it says select bodies for the load, so this one I have selected left column, and the load on left column is 15 in positive x-axis direction, so done. So component is minus 15 e raised power 3. Leave that component to empty. So it is going, sorry, uh, it is going opposite to that. So I need to change it. So sorry, it is along positive x-axis 15. And now the second load, it is load 2, static load, category mechanical type line load. So I'll go there, done, and then you have component and its value is 10 kilonewton, so that load is being applied. Now the third one is now again static load, and that is on left rafter, it is 12 kilonewton. So I'll continue, select that rafter, and then done, and then system, I need to use that local system, and it is actually acting downwards, so it will be 12 e raised power 3. So you have that load being applied. Now the fourth load, load 4, static load, and again category everything is same. So I'll select that right rafter, done, and the load here system is local, and then it is 12 e power 3. So you'll have that load. So click on the loads to make sure that is the 15,000 on left column, 10,000 on right column, 12,000 negative downward to the local in left rafter, and then right rafter it is 12. So now you have applied all those loads. Okay, so once you have done all that, then you need to uh, perform analysis. And for that, you need to create job, then data check and submit. So for analysis, you have job here, or in the module, you can go job there. Okay, so you can click here to create job, and you can double click here to create job, and it is going chapter 4, and without spaces, chapter 4 example, and continue and leave everything as it is. So you'll have here chapter 4 example, job has been created. So I'll first perform data check to make sure that the model is correct, or all the steps are correct. So it is running and it takes some time to complete. So check is completed. Once check is completed, then I'll go to submit job. So otherwise you can go there. Here you can submit job. It's a job already exists. Okay to overwrite. So that is being overwritten. So it is being submitted, then running, and it will take some time to. So the job has been completed. So I can go to results. Right click on that and go to results, and you can see here. So that is results. So there is another way. I'll go file open, and then that is a ODB. So I can open it from there. So now in the visualization module, you can have that this is plot undeformed shape, and in common options, you can go to labels. So show node labels, apply, and you have these node labels. So 1, 2, 3, 4, and 5. So these are the principal nodes, and that is a deformed shape. And this one is deformed shape with the contour plot, and that one you have here. That one you have there, both deformed and undeformed. Okay, so I'll just click on deformed. So you have one Mises stresses. Then these are the strains on deformed shape. These are the reaction forces. You can see only reactions are at node 1 and 5. Then reaction moment. So there is no reaction moment here. And then that is, these are the stresses, one Mises stresses. That is the displacements, magnitude. And then you have 1 and U2. Then you have UR3. So that is, you can, here, you can visualize the results, and then you can create report, field output, and you have here uh, option, position, integration point, unique node, and what I want to just get, let's say, reaction force 1, 2, and reaction moment. Then I want U1, U2, and UR3, and then I'll click apply. Oh no. So, and then go to setup, and then I can say it's chapter 4. So that report with the name chapter 4 example that has been created in the work directory. So I say apply, and here you can see it is a chapter 4 example report. So you'll have their reaction forces in X direction, reaction force in Y direction, reaction moment along x-axis. Then these are the displacements. So you can create in report, you can generate report like whatever you want. If you want any stress components, so you can go for that one. Or if you want to look for strain components, so you can go for that one. And I hope that you like this video tutorial. You can leave comments for your feedback. Thank you very much for watching.